You've waited for it. You've been looking forward to it all year. Here it comes, the new movie called Resistors in Series. Dun 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 dun. It is a single, long, lonely path. Our hero, the Ampere family, sets out on a quest. They come prepared for their quest with voltage, an ancient form of currency. Now they must use all their voltage on their quest. They will return to their house, tired and broke. So they're gathered at their house. And as they're gathered at their house, there's the Ampere family right there. They're in an area of high potential right there. Their quest will take them through R1. Their quest will then take them through R2. Their quest will then take them through R3 and then back to their house. Remember, all members of the family have to get back to the house, so every one of the Ampere family has to get back to the house. But along the way, they'll spend their voltage and use it up. So whatever the voltage they start with here, they will end up with 0 there. So the voltage drop across there is going to equal everything. They're going to use up all of their voltage. Now, as they leave on their quest, they must pass through 3 challenges. They must go through the 2 ohm challenge. They must then go through the 4 ohm challenge. They then must go through the 6 ohm challenge. The ohm is what works against them, the challenge they have to overcome on their quest. So if we take a look at it, they have to overcome a total of 12 units. 12 ohms on their quest. They only have one path. They have to go through all the parts. They don't have an option. Now the Ampere family starts with 24 volts of ancient currency. And they have to use it up. They have to get back to this side with 0 volts. That's just the rule. And they can't change the rules just because they're the Ampere family. They have to use them all up. So now what we're going to do is use that law, that wonderful law created by George Simon Ohm. Ohm's law, what a wonderful power that George Simon Ohm gave us. He allowed us to calculate one of V, I, and R as long as we knew the other 2. So I need to find out I total. I total would be the number of members of the Ampere family. And that's simply V total divided by R total. And that's 24 divided by 12. There are 2 amperes in the family. So it's 2 amps there, 2 amps there, and 2 amps there. Now, as they begin their quest, they leave here, both of the Ampere members of the family. They must go through the first quest. The first quest, they have to figure out how much voltage to spend. Well, according to Ohm's law, dun 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 dun, they must spend 2 times 2. They must spend 4 volts to get through and answer that part of the quest. The amperes then continue, and they move through here. For this part of the quest, they must use Ohm's law again. Dun 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 dun. 2 times 4. They're going to use 8 volts to go through that path. Then they must continue on with their quest. And as they continue on with their quest down through here, they must go through this 6 ohm resistor. In order to go through the 6 ohm resistor, they must again use Ohm's law. Dun, da, da, dun. 6 times 2 is equal to 12 volts. As they've gone around their path, they have used 4 volts and 8 volts and 12 volts. They have used up all of their 24 volts on their quest. They're home. They're back to this point right here. But they're out of voltage. They're tired. But the Ampere family has got home. Remember, when you're traveling in a series quest, you have but one path to take. So therefore, the amperes must be the same. The current must be the same. You must use up all of your money, your voltage. Your voltage must be drained from your pocket by the time you get back to your home, the lovely battery where you live, right here. It's where you spend your downtime. The rest of the day you spend out gallivanting around on quests. Look for this movie in a theater near you. So if you want to really understand series circuits, you need to remember a couple rules. First of all, the current is going to be the same in every part. You have no choice. You must go through all the quests and all the challenges. The voltage drop is going to add up to the source voltage. So around the loop, you're going to lose all of the voltage. Okay, of course, you can always do it with verb tables. So remember that when you draw your verb table, you're simply going to go like that. V, I, R, P for power. And then you have R1, R2, R3, and total. And verb tables are wonderful things because if you know 2 things on a line, you can figure out every other thing. For this one, we know that we had 2 members of the Ampere family, so those were all the same. We know that we had a total of 24 volts. We know that this was 12, this was 8, and this was 4, because we know that 4 divided by 2 is that. 8 divided by 2 is that. 12 divided by 2 is that. If you add them up, you get 12, and the math gods are happy. And then, of course, power is V times I. So you have 8 watts and 16 watts and 24 watts, and you have a total of 48 watts. Notice how everything works out, all that. Verb tables make it easy to do the math, but the concept, again, is the fact that the current has to be the same in every part, and the voltages add up. Hope this helped. And remember, part 2 is coming.